Welcome back, Physics 30. We're going to look at part 5 now from the vector and scalar quantities section. This pertains to pages 32 to 35 of your duotang, so you can look through that if you need to. And the objectives for this lesson include demonstrating an understanding of vector addition and vector subtraction, the big one being vector subtraction, and illustrate the different results that vector and scalar operations yield. So if we take a look at this, you have this on your front page. I just redrew it here, and I made these to scale, so if you actually measure this vector A, it's 6 centimeters, and vector B is 4 centimeters, and west and north are their respective directions. So if we take a look at the next page, determine the result of A and B. So take a minute or so, draw that out underneath here, pause this video, and we'll take a look at it. So if you had enough time to draw that, vector A looks like this, and then placing vector B on where you left off. Both have arrowheads, form a right triangle, and the resultant from start to finish, if you measured that out, you would see it's 7.2 centimeters. And in terms of direction, we can say from straight west, it's around 32 degrees north. Or if you chose to measure it this way, because it's a quadrant 2 vector, you can do it one of two ways. North and around 57 degrees west. So either answer is acceptable. You don't have to give me both of them like before, just one of them. Okay. Now if we take a look at the next question, what if we have vector B plus vector A? So the reverse order. So again, pause the video right now and draw that out. Okay, so if you had a chance to draw that, vector B, then vector A, the resultant from start to finish, again at 7.2 centimeters. And if we're measuring this angle, it's north 57 west, just like up here if I had chosen to measure that. So you can see, or west 33 north, vector addition, order doesn't matter. You can add 1 plus 2 or 2 plus 1, you get the same result, just like you would arithmetically. So if you look at number 2 here, after reading page 32, vector subtraction, what we do here is, when I mentioned this earlier on in another lesson, change it to adding the opposite. Really, subtraction is really the opposite of a number. So 8 minus 3 could be thought of as 8 plus negative 3, or the opposite of 3. So if we're doing this question over here, determine the result of vector A minus vector B. Think of it as vector A combined with the opposite of B. Now the opposite of B is simply the same vector but pointing in the opposite direction. So if B is 4 centimeters north, negative B is 4 centimeters south. So if we draw that, vector A is the same as usual, going to the west, but now vector negative B is going south. So we figure out the resultant. We get the same magnitude, but the direction is not the same. You can see it's a quadrant 3 vector, west 33 south, or if I had chosen to measure it this way, south 57 west. Okay? So again, if vector B is 4 centimeters, negative B is 4 centimeters south, the opposite direction. So it's different. West 33 south, west 33 north, so you can see it does change the direction. Vector subtraction gives you a resultant that is different. I'll get you to do this one. How about just regular vector B minus vector A? So again, think of it as add the opposite of A. So pause the video right now, draw that out, and see how that answer compares to this one. Okay, if you had time to do that, vector B is as it was previously, but now we're taking the negative of A. So originally, of course, A was 6 centimeters west. The negative A is 6 centimeters east. So if we take a look here, what we get, the same magnitude again, but again, you can see it's pointing in quadrant 1. This resultant vector is pointing up to the right. So same magnitude, but north 57 east if you measure it, or east 33 north as compared to west 33 south up here. So it does change direction. So after completing this, does the order matter in which you do vector subtraction? Yes, it does. The order makes a difference because you're taking the opposite of two different vectors in both cases. Okay, so vector addition, vector subtraction, treat it as vector addition, just simply adding the opposite. If we look at multiplying and dividing now, vector quantities, if we have vector t is 2.2 centimeters west 40 north, and if we're wanting to figure out 2 times t, you just simply double the magnitude. The direction stays the same, just double it. If I look over here at negative 3t, if we just don't worry about the negative sign for a moment, you take 3 times t. So 3 times 2.2, 6.6. But the negative means the opposite direction. The opposite of west, east. The opposite of north, south. So instead of west-north pointing this way, it would be east-south, pointing downwards and to the right. And divided by 2 is the same thing as multiplied by a half. So 2.2 divided by 2 is 1.1 centimeters. And again, the direction will stay the same because there is no negative in front of there. Okay. Let's see, the last page here. I think that's the last page. So given vector r, 4.5 meters north, 25 east, determine the following. So I'll get you to maybe pause the video right now, run through those, see what you get, then we'll look at your answers. So I'll pause the video now. Okay, if you had time to do that, so 3 times r, 3r, if r is that, you simply multiply by 3, 13.5, direction stays the same. Negative r, the magnitude doesn't change because we're multiplying by 1, but the direction is opposite. The opposite of north, south. The opposite of east, west. And lastly here, r divided by 5, so take that number divided by 5, it's 0.9. The direction stays the same. And then negative 2r, so double that number first, 9.0 meters. And then the negative sign implies, once again, the opposite direction. North becomes south, east becomes west. So fairly straightforward there. And then does multiplying or dividing a vector by a scalar change the direction? No, unless you have that negative sign in front. Okay, so that's it. So vector addition, subtraction, multiplying and dividing. So you're ready to do the quiz for this now, and we'll see you next time.